Good morning, Steamsters. Let's get right into it. So, first of all, Wednesday we'll have a Kahoot at noon. Make sure and be there, like maybe a little before noon, because we will have to be done by 12:30. Because I have to be in Fort Collins for a knee appointment at 1:15. So don't be late for that. And then the brain stretcher yesterday. Mount Everest is 29,029 feet above sea level. So imagine, if you've ever climbed, any of our 14ers in Colorado, okay, double that. And wow, that's that'd be a heck of a jaunt. So, let's see. So today I've got just a few things. I want to go over that pre-assessment. Thank you for everybody getting that. And we're going to be talking about the atmosphere, and I'm just going to kind of throw a few random things at you today, and then some of that will be covered in the Kahoot tomorrow. So let's go over that pre-assessment. Okay, so once again, I went to 7th grade science. And we'll do the English one. Okay, so just looking at or thinking about your answers from yesterday. Okay, so number one, so here's the waves. And so waves kind of just go along like such. So the point from one point on this wave to the next point on the next wave, this would be called the wavelength. So number one was wavelength. Frequency is a little different, because a lot of people put frequency on that. 2, amplitude is the height of the wave. So if it was a higher wave, so say it went wee, it'd have a higher amplitude. So the distance from the middle to the top, or from the middle to the bottoms, they'd be the same. That is amplitude. 3, just the crest of the wave is the top part, and then the bottom part of a wave is the trough. Think about like a hog trough or feed trough. All right, so there's that. Now, light gives off, as far as like the light from the sun, well, there's a lot more in it than just the light that we see, because really we only see this very narrow band of visible light, which will show that. And so there's actually radio and TV waves, microwaves. There's actually X-rays and gamma rays in the sunlight. Most of those get filtered out by our ozone layer, so anyways, there's a lot of other things in the light besides just what we see. So 5 is going to be about radio, radio waves, because those are radio and TV and cell phones. They're all using radio waves. Number 6 is microwaves. 7, this is a biggie. We'll talk about it a lot. Infrared. So that is what gives us heat. 8 then is the visible light, and once again I'll show you something with that here in just a minute. So the 6 colors are red, orange, yellow, green, blue, and violet, and then everything else is made off of those. Number 9, it's ultraviolet light that causes our skin to burn if you're exposed to the sun too long. 10, well, we do use X-rays for medical uses or for security purposes. And then the most intense, the highest frequency waves or rays are the gamma rays. Those are for like radiation treatments. And so they would be really high on the frequency spectrum there. All right, so that's a little bit on the pretest. Yeah, most people did pretty good on. So today I got a couple of clips from or demonstrations from things I did outside. One's about visible light, and then one is about infrared energy way up in our atmosphere. So let's and make sure you go, if you didn't go to the brain structure, do that today too with the solar powered cricket. But let's continue on with that visible light and what makes that up. Now, white light, as we see it, it appears just white, but it's actually a combination of all the colors of visible light. So ooh, look how pretty that is. Take it away. That's how we see it. Now these are just spectroscopy glasses, so what it's actually doing is breaking that white light into the individual colors that we see, and it's all based on wavelength, red, or frequency I should say. The red has the lowest frequency, the blue and violet have the highest frequencies, and so they're always going to be in that order of red, orange, yellow, green, blue, violet. But that's how it really is. That's how we see it. Kind of cool. Okay. The next one involves using an infrared thermometer. So this was being shot on Monday, though you're going to be watching it on Tuesday. It's clear, blue day, sunny day. We had is about 78 degrees here in Loveland. It's a warm day, but how hot is it way up there in the atmosphere? We're going to test that. So this thermometer tells how much heat something's given off, because right now it's about 70 degrees here outside, but different objects are going to have different amounts of heat coming off of them. So for instance, the white vehicle, it's at 95, 96 degrees, whereas wifey's car, which is a darker gray, what do you think? Ooh, a lot hotter. So it's Monday morning at 7 o'clock, and right now it is 41 degrees here in Loveland, and you can see we've got clear blue skies. So using our infrared thermometer, ooh, it's pretty cold up there, -4 degrees. Okay, let's check back here in a little bit. Now here it is 9 o'clock, it's 55 degrees here. It's still just 3 degrees up there. Okay, thank you for watching. Just wanted to throw some information at you. So that's it for today. Tomorrow, once again, 12 o'clock. Show up a little before then, because yeah, that Kahoot will get going at 12, because I have to be done by 12:30, and we might even have a prize for the winner. All right, see ya tomorrow.